Sir Isaac Newton was the first to state the law of gravity. Eventually, everybody agreed that gravity alone formed galaxies and stars and planets, and that gravity alone holds the universe together. Then we discovered a force 1,000 billion times more powerful than gravity. Until recently, we believed that the space between the stars and planets was empty, a vacuum. We now know it is teeming with charged particles. We see glowing electric filaments spanning millions of light years. We see stellar and galactic formations shaped by magnetic fields. Only electric currents create magnetic fields. It is possible that the predominant force in the universe is not gravity, but something else.
Throughout almost all of history, we have regarded the states of matter as being solid, liquid or gas. But in the last century or so, we have found that there is a form of matter where the charged particles within atoms are separated to some degree or another, and that is known as a plasma. It is the fundamental state of matter.
It was not until the second half of the 20th century that we came to realize the role of plasma in the universe. And this has changed the picture of space completely. Not long ago, we thought of the physical universe as being constituted, fundamentally, of nothing more than atoms and empty space. But a plasma includes at least a percentage of charged particles, protons and electrons, that are not bound to any atomic structure. And plasma is an excellent conductor. Electrons will move efficiently in the direction of charge equalization, and that's an electric current, of course. Now, the reason why we see magnetic fields everywhere we look in space is because electric currents produce magnetic fields, and only electric currents produce magnetic fields. But astronomers working only with gravitational equations did not anticipate the discovery of pervasive magnetic fields in deep space. Electric currents also account for the abundant filamentation of space plasma. First, the electric currents produce the magnetic fields. Then these fields confine the electron flow to narrow paths. Such current paths, or filaments, are called Birkeland currents, named after the pioneer Christian Birkeland. They are typically braided just like the twisted wires of transmission lines on Earth. Well, that's their role in space, to conduct electricity across vast distances, creating the astonishing structures we observe in every direction. None of these structures were anticipated by gravitational theory, and none are indicated by the behavior of neutral gases in a vacuum.
In any theory of the universe, plasma is extremely important because it has been found since the space age that it makes up 99.99% of the visible universe. So our inexperience with it on the Earth's surface is rather crippling when it comes to trying to decide on a cosmology to explain the visible universe. Now, plasma behaves rather oddly compared to normal matter, the matter we find, the solids, liquids and gases on Earth. If you look at a novelty plasma ball, you will see that it forms these bright filaments that dart all around inside the globe. And if you look closely at them, you'll see that they're actually twin filaments twisted together. In other words, nature finds it efficient to be able to transfer energy over a distance by twisting two pairs of filaments together. And this is a characteristic of the way plasma carries electric currents in space. And one of the puzzles that has faced astronomers since the space age is the discovery of filamentary structures in galaxies, around stars, even the cometary tails of planets and comets themselves. These filamentary structures have come as a surprise. We now have plasma physicists who are doing important experiments in laboratories around the world, and one of the virtues of plasma experiments is that they can be scaled over an enormous number of magnitudes. In other words, a discharge phenomenon that may be seen in the laboratory that occupies only a few centimetres can be scaled up to the size of a galaxy, and you will see the same structures. Now, this introduces a new area into cosmology where we can do experiments on Earth which can verify our ideas, our theories about how the rest of the universe works.
Are the patterns that we see, both in the laboratory and in the sky. A very good example of this is the work of Dr. Anthony Peratt, who was a graduate student of the very famous Hannes Alfvén, who was really the father of electric cosmology. Peratt simulated on a supercomputer using just a cloud of electrical charges and a magnetic field, just using the laws of electrical science, not using anything to do with gravity. He simulated what looked like a spiral galaxy. And the interesting thing is that Peratt's spiral galaxy in the laboratory had exactly the same rotational properties as the real spiral galaxies that we see in the sky do.
The new instrumentation that was developed in the space age expanded our ability to perceive things, perceive facts. We could now see things in the entire electromagnetic spectrum instead of just the narrow sliver of visible light.
What you're seeing is the actual moment of deploy there when we take the switch to deploy, and it's so quiet.
And we had sensors that were out in space. We were freed from the geocentric and anthropocentric order that had prevailed before. We've got a whole new universe, and the theoreticians are still trying to look at it through, a friend of mine says they're peering through the wrong end of the telescope and telling us what they imagine they see.
Modern cosmology gives us a rather disconnected view of the universe. In other words, we are separated star from star by vast distances. Light takes a long time to travel between stars and across galaxies, and therefore we look upon ourselves as isolated and disconnected. The electric universe takes a different view. It says that we are a part of the sun's environment, the electrical environment, and the sun is a part of the galactic environment, and the galaxy itself is strung, like all galaxies, on huge electric currents flowing through the universe.
One of the typical questions that plasma cosmologists hear all the time is, how do you know what's out there in space? How do you know there's electricity out there in space?